These are our 3-6 graphing lines notes. The slope-intercept form of an equation is y equals mx plus b. This m right here stands for the slope. And b stands for the y-intercept. Here's an example. 4x plus 8y equals 24. This form right here is in standard form. Standard form is ax plus by equals c. So the x and the y are on the same side of the equal sign. So if I wanted to graph this, step 1 would be to put the equation into slope-intercept form. So I'm going to take this equation and make it look like this one. I need to get the y by itself in order to do that. I'm going to subtract 4x from both sides. So we would subtract 4x so I get 8y equals 24 minus 4x. Then I would divide both sides by 8. So now the y is by itself. And I get y equals, and I can simplify this side, so 24 divided by 8 equals 3. So we would say y equals 3 minus 1/2 x. So in this equation here, the number in front of the x, which in this case is 1/2, is my slope. And then the number or the constant, the b, that's my y-intercept. So if I go to graph it, you can see this is what I'm working with. So writing this in proper form, we would have y equals negative 1/2 x plus 3. Again, this is my slope, and this is my y-intercept. So now we want to graph the y-intercept and graph the slope. So now we have this in slope-intercept form, and the way I graph it is I can start with my y-intercept, which is right here. So it's 3 in this case. So on my y-axis, I go to where y equals 3. So we just go 1, 2, 3. And plot your y-intercept. Right there, we can see it. And then from there, you can count your slope. So if my slope is negative 1/2, remember, negative 1/2, and when we're talking about slope, we have rise over run. From this point right here, my rise is negative 1/2, and since it's negative, I'm going to go down 1. So we go down 1. And then my run is positive 2. So I'm going to go down 1 and to the right 2 and put another dot. So down 1 to the right 2 and put another dot. Down 1 to the right 2 and put another dot. Down 1 to the right 2 and put another dot. Connect them, and that's my line. So we can connect these, and that is going to be our line. Here's another example. Y equals 3x plus 1. My y-intercept is 1. So on the y-axis, I'm going to plot 1. So I go to the y-axis and go up 1, and I plot that point. And my slope is just 3. Written as a fraction, it would be 3 over 1. So my rise is 3, and my run is 1. So we go back to our line, and we're going to go up 3 and over 1. So 1, 2, 3, and over 1. 1, 2, 3, and over 1. 1, 2, 3, and over 1. And here's my line. In this example, it is now written in standard form, and we need to try to get it into the slope-intercept form so that we can graph it. So I'm going to pause the video, and you try to put this into slope-intercept form. Remember, we want to get the y by itself. So I'm going to subtract 2x from both sides. These cancel, and I'm left with 3y equals 6 minus 2x. Then I'm going to divide off my 3 from both sides. These cancel, so you're left with y equals 2 minus 2/3 x. So written in slope-intercept form, we have y equals negative 2/3 x plus 2. So when I go to graph it, my y-intercept is 2. So on the y-axis, I'm going to find my 2. So we go up 2 and plot that point. And then my slope is negative 2 over 3. So my rise is negative 2, so I go down 2, 1, 2. And over 3 is my run, so 1, 2, 3. And I plot that point. And again, down 2, over 3, and plot that point. Down 2, over 3, so here's your line. When graphing lines using intercepts, we're just simply going to plug in 0. So if it's an x-intercept, you plug in 0 for y. If it's a y-intercept, you plug in 0 for x. So in this case, x would end up equaling 3, y would equal 9. So if we're looking at the coordinate pairs, this is what we would see. So to graph this, we would simply place our points at those locations. So for the y, we're going to, remember, place a 0 for x, so y would equal 9. So I'm just going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9. This is where I would plot my point. And for the x, x equals 3 because we just place a 0 for y. And so 9 divided by 3 would give us 3. So we go over 1, 2, 3, plot our point. And this here would be our line. That's if we're graphing lines using intercepts. Writing an equation in point-slope form. Here's the slope formula, right here, y2 minus y1 over x2 minus x1. And then this one is the point-slope form. So you can see here what we're using, y minus y1 equals m times x minus x1. So one example would be, write an equation of a line through 2, 4, and 5, 1, through those coordinate pairs. So we can identify our first points as x1, y1, and x2, y2. And then this point here, so here was our x2, y2. And in this formula right here, the m still stands for the slope. So in order to write the equation, I need to figure out what the m, or the slope, is, and the way that you do that is by using the slope formula. So I'm going to calculate y2 minus y1. So in this case, it is 1 minus 4, so that would be negative 3, and 5 minus 2 would be 3, and negative 3 divided by 3 reduces to negative 1. So this is the number that you just found that is your slope, or your m. So step 2 says, plug in a point for x1 and y1. And then your coordinates. So we're looking at these coordinates here. I'm going to plug the 2 in place of my x1 and the 4 in place of my y1. So to write this equation out, when we plug in these points, we would have y minus 4, which was my y1, equals our slope we figured out here is negative 1 times x minus our x1, which is 2. This is the equation in point-slope form. Going along with what we just learned for the point-slope form, here are a couple examples for you. Write an equation in point-slope form given, here's your point, 4, 1, your coordinate pair, and the slope is 3. The second example is to write an equation in point-slope form given 2 points. So in this case, you've got your 2 points here, and we are going to write that in point-slope form. I'm going to pause the video and give you a chance to try this. Here's what you should have found for your answers for each of these problems when they are written in the point-slope form. This one you had to actually solve for your slope first and then plug it back in so that you could write it in your point-slope form. down here,